When NASA sent the twins into space, they thought it was the perfect way to study human biology beyond Earth. Mark and Scott Kelly, identical twins born and raised together, would offer a rare glimpse into how space affects the human body. One stayed on Earth, the other spent nearly a year aboard the International Space Station. It was supposed to be science made simple. A natural control. Mark would age normally. Scott would age slower or differently in microgravity. They expected some changes: bone density loss, muscle atrophy, DNA methylation shifts, but nothing that could prepare them for what came next. I'm Dr. Laura Michaels, part of the team analyzing the NASA Twin Study data. We sifted through genomes, telomere lengths, gene expression patterns, all looking for the subtle fingerprints space leaves on us. At first, Scott's time in orbit seemed to confirm what we expected. His telomeres, those protective caps on chromosomes, lengthened. His genes showed unusual expression profiles. His body seemed to age slower in some ways. Mark, meanwhile, aged naturally on Earth. But then the anomalies started. When Scott returned, we expected him to simply reverse his space-induced changes. Instead, we found that Mark had aged 20 years in just 6 months. It wasn't gradual, it was sudden, aging on fast forward. His skin had wrinkles no man his age should have. His hair thinned. His joints creaked. We checked and rechecked the data, the samples, the scans. But it was true. Meanwhile, Scott's aging had nearly stopped. His DNA showed minimal changes. His heart and muscles stayed almost pristine, like he'd paused time in orbit. We'd thought twins shared nearly identical DNA. But now, it seemed space had rewritten the rules. Their genomes were no longer matching, by over 30%. They no longer shared the same DNA. Mark's cells bore scars, mutations, deletions, oxidative damage. Scott's cells bore secrets, changes no one understood. It was as if the two bodies had diverged into different species. Something in space didn't just alter Scott's body. It transferred something. Something that accelerated Mark's aging. Something that made them opposites. The question hanging over us was terrifying. Had the mission created a biological rift too vast to repair? Had space broken the twins, and maybe, by extension, all of us? After Scott Kelly's return from space, the data poured in faster than we could process it. We sequenced blood samples, skin biopsies, saliva, hair follicles, every cell telling a different story. At first glance, you'd think identical twins would be genetically indistinguishable. But Scott and Mark's DNA had diverged. It wasn't just a few mutations, it was a wholesale change. We found that Scott's DNA showed dramatic epigenetic remodeling. Thousands of genes were switched on or off in patterns no human had ever displayed before. It was as if space had rewritten the manual inside his cells, giving him a new set of instructions to live differently. Mark's DNA, however, was unraveling. His telomeres, the chromosome end caps responsible for preventing cell aging, were shortening rapidly. His cells were flooded with oxidative damage, the kind usually seen in patients decades older. His mitochondria, the tiny powerhouses inside cells, were breaking down. His immune system weakened. Mark was aging fast. But it wasn't just that. We saw something worse. His DNA was fragmenting. Pieces were missing. Sections were duplicated. Random sequences appeared. It was as if the fundamental blueprint was tearing apart. Meanwhile, Scott's genome looked almost alien. It carried genetic signatures that didn't match any known human pattern. Some sequences resembled viral DNA, but unlike any virus cataloged, others looked like synthetic edits, complex and intentional. His cells seemed to have gained the ability to repair damage instantaneously. His tissues healed faster, muscle regeneration was accelerated, and his cardiovascular system showed signs of extreme efficiency. But it wasn't clear how. The epigenetic data suggested Scott's body had activated a new biological program, one that went beyond normal human adaptation. We hypothesized that long-term exposure to cosmic radiation and microgravity had triggered latent genomic pathways, or maybe space introduced unknown factors, microparticles or radiation bursts that rewrote cellular instructions. Either way, the result was a split. Two brothers no longer bound by shared DNA. The consequences were profound. Mark's rapid aging left him fragile, vulnerable to diseases usually seen in the elderly. Scott, on the other hand, was physically in his prime. But something about his new biology was other. His immune profile suggested he might not react normally to pathogens, and subtle neurological scans hinted at altered brain function. His cognitive tests were mixed, some abilities enhanced, others diminished. Memory recall sometimes failed. At times, he exhibited what researchers termed alien cognition. His thought patterns were non-linear, processing information in ways no one could fully understand. The divergence extended beyond physical and cognitive. We found evidence of biochemical signals exchanged between the twins, not just emotional or familial, but molecular. Scott's cells seemed to send unknown proteins through the bloodstream. Mark's cells responded with stress signals. It was as if Scott's body was sending something harmful to Mark, a biological message, or a weapon. The implications were staggering. If spaceflight could cause this kind of split in identical twins, what could it mean for long-term colonization? What if every astronaut return changed, and worse, brought back consequences for those left behind? NASA quietly adjusted future mission protocols. No more twin studies, no more solo year-long flights without comprehensive genomic safeguards. But the study was out. Scientists worldwide began to question the limits of human biology. Was our DNA truly fixed? Or was it a malleable code, vulnerable to cosmic rewrite? And what did that mean for identity? The physical changes between Scott and Mark were only the beginning. As the months passed, the psychological and emotional rift between the twins grew more profound and disturbing. Mark, once confident and vibrant, became withdrawn and anxious. His mind felt clouded. He struggled with simple tasks, his memories fragmented. He described waking up in strange places without knowing how he got there. Nightmares plagued him, visions of blackness swallowing time and space. He told us he felt like he was losing himself, like someone else was writing his story now. Scott, in contrast, became distant in another way. His thoughts raced too fast. He spoke in riddles. At times, his voice flattened, devoid of emotion. His dreams were vivid but alien, sometimes filled with starscapes and impossible geometries. He admitted feeling disconnected from reality, like his mind was moving on a different plane. The most alarming moment came during a neuroimaging session. Scott's brain scans revealed heightened activity in areas linked to spatial awareness and pattern recognition, but suppressed signals in the emotional centers. Mark's scans showed the reverse, emotional centers firing erratically, cognitive regions shutting down. It was as if they were becoming complementary opposites, two halves of a fractured whole. Their relationship suffered. Once inseparable, the brothers now seemed like strangers sharing the same DNA by accident. They would speak, but conversations dissolved into silences or cryptic statements. Mark accused Scott of stealing time, of living a life frozen while he aged rapidly. Scott said Mark was trapped by his body's limits, unable to evolve, but underlying their conflict was something deeper, a creeping fear that their biology was no longer theirs to control. The most harrowing revelation came from genetic data. We discovered fragments of Scott's altered DNA circulating in Mark's blood, not as contamination but as messengers, proteins encoded with signals capable of influencing cellular behavior. It was a biological call and response, but Mark's body interpreted these signals as threats. Inflammation and accelerated aging followed. It was a cellular war playing out inside them. At the same time, Scott's body showed signs of enhanced regeneration, but also increasing genomic instability. His cells were rewriting themselves, introducing errors and edits, like an evolving organism. The line between human and something else blurred. The twins' shared childhood memories became a source of pain. Mark struggled to recall moments that Scott could vividly replay. Scott sometimes whispered that the memories he held were not his own, that somewhere in his mind there was a space reserved for someone else. Someone, or something, he couldn't name. Both struggled with identity. Who were they now? Were they still brothers? Were they still human? The public knew little of these details. NASA kept the full extent under tight wraps, but inside the team, whispers spread. Some feared the study had opened a Pandora's box, that space travel was rewriting DNA in ways no one could predict, and that the twins' divergence was just the first symptom. What happened next would test the limits of science and family. The final chapter of the NASA twins study was not the breakthrough we hoped for. It was a tragedy. Mark's body continued to decline. His cells fractured further, his heart weakened, and his mind slipped deeper into confusion. He lost the ability to recognize faces, including his own. The doctors tried everything: experimental therapies, gene editing, regenerative treatments, but nothing could stop the relentless aging. Scott, meanwhile, remained a mystery. His body defied every expectation. He was stronger, faster, seemingly immune to the decay that claimed his brother. But that strength came at a cost. Scott's genome was no longer stable. He exhibited strange mutations, some beneficial, others unsettling. His eyes occasionally flickered with iridescence. His sleep cycles defied natural rhythms, and he reported hearing whispers in the silence, messages he couldn't explain. The twins, once inseparable, now lived worlds apart. Mark in hospital rooms, fading fast. Scott in isolation, monitored as a scientific marvel. One day, Mark whispered through a respirator, "I don't feel like me anymore." Scott responded with a strange calm, "Maybe you're not. Maybe I'm the new version." But beneath the words lay something darker. A fear neither could voice, that the space between them was more than distance. It was a chasm in their very DNA. We found that the changes to their genomes had broken their bond. Their DNA was no longer mirror images. It had split, evolved apart. And as the months passed, it became clear this divergence was irreversible. One final experiment was proposed to test whether the twins' altered DNA could be reunited, a risky cellular fusion. But both refused. Mark, too weak to endure. Scott, too uncertain if he wanted to become whole again. Their story ended quietly. Mark passed away, surrounded by a team that grieved not just the man, but the loss of what they thought humanity could withstand. Scott remained, a living testament to human adaptability and its terrifying limits. The NASA Twin study revealed more than the effects of space on the body. It revealed that identity isn't fixed, that our DNA can be rewritten, not just by the environment, but by forces we don't yet understand. That even the closest of bonds can unravel at the molecular level. And as we prepare to send more humans beyond Earth, we must ask, are we ready to face the changes that await us? Or will we become strangers to ourselves and to each other?